Press star 0. This conference is in silent mode.
Myself and what we're doing on the Mars Science Laboratory mission, as well as today we're going to talk about roving on Mars. So I'm really excited to share with you. If any one of you is having a hard time hearing me, please let Paige and I know in the chat window. We're really glad that you guys could join us today, and I see some familiar schools out there, so welcome back and welcome to the who are new. I'm really excited to share with you guys today all this information about roving Mars. So this is what we're going to talk about today, is roving Mars and our vehicles that we've sent to Mars. Now, here we have a bunch of successful missions that we have sent to Mars, and we have our orbiter missions, which started in the 1960s. In the mid-1970s, we not only sent an orbiter, but we sent landers too, and these were the Viking landers. And then we took about a 20-year break, and it wasn't until the late 1990s that we sent another orbiter and our other landers to Mars. And since then, in the mid-2000s, we've been sending a bunch of orbiters and landers and rovers to Mars. And we're really excited to talk about some of those rovers today. But first of all, I have a question for you guys, and here's what we're going to ask. Is I have 3 pictures up here labeled 1, 2, and 3. Can you guys tell me in the chat window which one is a rover, a lander, or an orbiter?
So using that chat window, give us a number and then what you think it is. So whether number 1 is a lander, orbiter, or a rover, or just what you think. And hopefully you should be able to detect that, but we just want to make sure that you can. So go ahead and make sure your chat window is set to send to everyone and give us your potential answers. What's a rover, what's a lander, and what's an orbiter? So Gates Intermediate is shared. Leon Springs from Texas has shared. 1 is an orbiter, 2 is a lander, 3 is a rover, as well as Lewis F. Mayer Middle School. They seem to be in agreement there as well. While you're thinking about that, if you've already put in an answer, how do you know which is the rover? If you want to add that in as you're thinking about the rover, lander, orbiter thing, if you want to add in how do you know which one is a rover, certainly let us know.
Wow, we got some great answers out there, Paige.
And, you know, it's almost some of the images, especially with number 1 and number 2, it's hard to tell whether or not these things are on the surface, whether they have wheels, but these schools have made that observation, and so they can certainly see these 3 types of missions we've sent to Mars.
Wow, you guys are great, and you're exactly right. Number 1, we have an orbiter, and orbiters are just like satellites that we have here orbiting around Earth, except they orbit around Mars. And then landers, like you guys have noticed, don't have wheels, and wherever they land is where they do their science. And then we have rovers, which have wheels and are able to move away from their landing sites and explore other parts of Mars. So really great job, everyone. So let's just see. If we want to land a lander or a rover on Mars, how do we do that? You know, it's one thing to have a satellite traveling around Mars, but how do we land on Mars? And I think that's a great question, and I have a video I'm going to share with you guys that explains a little bit about this.
So 3 ways, 3 options. Keep that in mind and think about that.
So that was just a quick look at how we've landed some of our rovers and landers on Mars. And as you can tell, there's a lot of engineering and a lot of design that goes into each of those systems. So next, let's take a look at our rovers on Mars. And we have sent 4 rovers and 3 different types. So the first one is our Sojourner rover, and it was sent to Mars in the late 1990s. Then we sent 2 MER-type rovers, the Mars Exploration rovers, and this was Spirit and Opportunity. And our latest rover in the family of Mars exploration vehicles is the Curiosity rover. And this rover landed not too long ago, actually in last August. So as you can see, they're all different sizes. Their wheels are different sizes. And one thing you'll notice is the Mars Exploration rovers, Spirit and Opportunity, and Sojourner have solar panels, while as Curiosity, we don't see any solar panels, and it's powered by a different type of radioactive source. So all of these things play into the importance of these rovers on Mars, what they can do, and how long they can last. So let's take a look at each of these. But I have a question for you first. So we know that Mars rovers can travel long distances, but how long, or what's the furthest that each of those has traveled? Which one do you think has traveled the furthest? Is it the Sojourner rover, which operated for about 83 sols, and a sol is a day on Mars. So it was on Mars for 83 days. We have the Spirit and Opportunity rover that lasted, and one still going. Opportunity is still on Mars and still chugging along. Those have gone for several years on Mars, and Curiosity that has been there not quite a year yet. So which ones do you think has traveled the longest distance?
So let us know in the chat window, and if you even have an idea of how far you think any of these rovers has traveled, you can let us know that as well. And so I'm seeing that many of you, perhaps looking at the dates there, are coming up with Opportunity. So actually I'm going to add to this question. Give us the order in which you think these rovers traveled as far as the longest distance. So if Opportunity traveled the furthest, who's next, and then who's traveled the least. So if you want to add that into the chat window, they all have traveled different distances. So you can tell us who's traveled the longest distance, or what order you think from the least to from the greatest to the least. So we've got some really good answers coming in. Leon Spring says Opportunities the most distance, Spirit, Curiosity, and then Sojourner. Freedom Middle School saying the least is the Sojourner rover. Freedom says that next is D, the Curiosity rover. And keep in mind these big wheels and the size of these rovers could perhaps play a role in the distances. So a tie between B and C. Now they are twin rovers, so some of you might be thinking they traveled the same amount of distance. Opportunity, Spirit, Curiosity, and Sojourner comes from Queen Creek. And Gates says the least is Sojourner, the most is Opportunity. Well, some really good thoughts and answers and good connections, I think, to the dates. Cherie, you want to share with us a little bit about some of these distances?
Let's take a look. You guys are just so smart out there. We got a great group with us today. And you guys are right. Everyone who said Opportunity, which I think was everyone, they have by far surpassed all of the other rovers that have been on Mars and have traveled 35 kilometers, which is about 22 miles. The Spirit rover, which traveled just over 7 kilometers, which is around 5 miles, and Sojourner, which has gone about half a kilometer, and Curiosity, which has traveled a little further than Sojourner with about 0.7 kilometers. So you guys are just right on. That's awesome out there. So let's talk about some of these rovers and see what they have done while they've been on Mars. But first, how do we design a rover? Now, there's a lot of engineering, a lot of thought, and a lot of creativity that goes into designing a rover. And I want you guys, have you ever seen this rover? And if you say no, that's what I said too. This is a rover, an early concept from the 1960s. And let me just show you real quick how this rover travels. It's quite different from what we see in today's rover. So let's take a look. So that was just a quick peek into what the early designs of Mars rovers were. And we've come a long way in 50 years. And here's some of the other types of rovers that the engineers at JPL have tried to design for Mars. And you can see that they've gotten a lot smaller from that first lunar prototype and look a lot like some of the rovers we send to Mars today. These were a class of rovers called the Rocky rovers. And there were about 7 of these that JPL engineers tested and built. Now, one of these Rocky rovers led to the development of the Sojourner rover. And this was the first Mars rover. It landed in 1997, and you can see in the background it was actually part of a lander. And then it drove off this ramp to explore the area around it. Now, part of the platform of the lander had a camera that could take pictures of the rover as it traveled around. And one thing you'll see here is this long antenna, and that's how the rover communicated. It would talk to the lander here, and then the lander would talk to the rover so it could tell it what to do and send it commands. So here's a picture of the rover, and you can see its ramp. This is where it drove off the lander and would drive around and explore different rocks on Mars. And here is a rock named Yogi. And this is one of the first rocks it explored. It has a scientific instrument on the end to where it could drive up and see what the composition of this rock was. And here you can barely see the little antenna there with how it communicated. And this rover was only supposed to last for 7 days. But guess what? It lasted for 83 days. And next I have a picture. It's this kind of funny looking picture. But imagine that you were holding a camera, and as you turned around, you took pictures around you. And that's exactly what the camera on the lander did, is it looked down and took pictures as it spun around to get a full 360 view of the area where it landed. And you can see in these white lines, this was the path that the Sojourner rover followed. Many rocks and traveled all around the lander for 83 days. And that was a really awesome experience for the Sojourner rover. And the scientists learned so much about not only the different rocks on Mars, but capabilities the rovers have and how to improve the next designs for our future missions. Now that leads us into the Spirit rover. And the Spirit was part of a two rover program, Spirit and Opportunity, that traveled to Mars, and Spirit was the first to land. And so here we can see Spirit's path. And until 2010, when Spirit was no longer worked, you can see all the entire distance that it traveled. It landed at the Columbia Memorial Station, traveled and visited a crater, and then went all the way to where it explored the Columbia Hills and a place called Home Plate. Now, there's a lot that Spirit has done, but some of you might wonder, well, how does the Spirit rover and other rovers on Mars actually drive on Mars? So let's take a quick look at how we drive our rovers on Mars.
And it's interesting because many people do think that these rover drivers are using sort of a joystick type of mechanism to get these rovers to drive around on Mars, but it really is all about commanding them. And it's absolutely interesting to think about the fact that these rovers, so far away from Earth, they do get our commands from Earth, or they're told to sort of think about how they can navigate themselves around any of sort of obstacles that are out there. So if you think about it, there is a bit of a delay between the rovers receiving those commands depending on the location of Earth and Mars. So that time delay can sort of be anywhere from 10 minutes to sometimes 20 minutes. So it's really interesting and intriguing to think about 20-minute one-way time. And by the way, you're not going to see a picture on your screen just yet. We have that sort of black video out there. But that 20-minute delay in actually the rover receiving commands, and then 20 minutes later for us to sort of get some information back from the rovers, that can really cause some havoc. And so that's one of the reasons why they gave the rovers this ability to be able to automatically get itself around some of these obstacles as need be. So it's really pretty interesting. So Cherie, thanks for sharing that video so we get the sense of no joysticks, just some good commands that get sent. And Cherie, go ahead and unmute yourself so we can hear you. Oh, there you go.
All right, thanks for filling us in with those extra details, Paige. So as you can see, it's really interesting how we drive on Mars. So to continue with Spirit's journey, let me tell you a little bit about what Spirit has done while it's been on Mars. So when you go out and look at the night sky, you might see things like the moon and stars, but you know what? Spirit does the same thing when it looks up. So what do you think these two bright spots are that Spirit has imaged in the Martian sky? So if you have any guesses, why don't you tell us in the chat window?
So we're not even going to give you any choices to choose from. We want to know from your perspective, what are these things? Is it the moon? Is it the sun? I see Earth and Sun from Leon Springs Elementary. Possibility of the moon. Now, is that Earth's moon or is it Mars' moon is an interesting question. Jupiter from Lewis S. Mayer Middle School. That's an interesting answer since Jupiter is so large. Freedom Middle School says maybe the small one is Earth and the large one is the sun. Deimos and Phobos, so Gates Intermediate has given us the names of the two moons orbiting around Mars. So we've got some, maybe Earth, the sun, stars. Anyone think those are stars out there? That was my first thought, actually. Queen Creek says Jupiter as well. That's a really interesting answer. Just, I wonder what Jupiter would look like. I'm not even sure what the answer to this is. So, Cherie, what is the answer?
Wow, I really like your guys' guesses about Jupiter because, Paige, I'm like you. Jupiter is a lot closer to Mars than it is on Earth, and it's so big. I wonder what it would look like in the Mars sky. Maybe we'll have to see if someone can take a picture of it for us.
Yeah.
But those are all really great guesses, and the answer is actually those are the 2 moons on Mars, and the names of those are Phobos and Deimos. So as you can see, just like we can look up in the sky and see our moon, the rovers on the planet on Mars can look up and see their moons. So really great answers out there. And you know what? I'm going to pass along your guesses about Jupiter and see if it's possible to maybe take a picture of it. I'll get back to you guys. I'm really curious about that now.
That would be awesome.
So some of you had guessed the Earth. And you know what? Here is a picture of what the Earth looks like from Mars. We look pretty tiny. And you can go out and look in your sky at night, and sometimes you can see Mars. And I bet it looks to be about just the same size. So that's really cool that we can see other planets from a different planet. So just to keep an eye on that, those are some really cool things that Spirit has done. Now, one of the biggest discoveries on Spirit actually was an accident. And as some of you might know, early on in the mission, one of the wheels on Spirit stopped working. And to do this, they always drove the Spirit rover backwards. So they would never drive forwards. It was almost like getting on a freeway and driving your car in reverse, although it didn't go quite as fast as you probably do on your roads at home. But while they did this, it kind of dragged along that wheel, and it uncovered this bright material. And so from that wheel dragging along, it ended up being one of the most important finds that Spirit has made. And this white stuff is something called silica. And scientists believe that in order to form this, it had to be a very wet past. And so this was one of the most intriguing discoveries and one of the best evidence that Mars had water on its surface in the past. So really one of the coolest things that an anomaly or an issue like a broken wheel actually turned out to be something very important while exploring Mars. Now, one thing that we talked about was that the Mars exploration rovers have solar panels. And because it is very dusty on Mars, you see that they get covered in this dust. And one problem is that if the solar panels get covered in dust, that reduces the amount of sunlight that can get to them. So sometimes we'll see that, you know, there's a decrease in power and not as much science that can occur on days where we don't have a lot of power. But there's something else that's really cool about Mars. And you know what? We almost have a Martian vacuum cleaner. And you can see these are dust devils traveling across the landscape of Mars. And every once in a while, when these dust devils go close by the rover, here's what it does. It cleans off the surface of the rover, and we get bright and shiny, clean new solar panels so we can have more power and are able to do more science and drive further distances. So it's really neat that we have a natural cleaner for dust on Mars. So one thing that we have to worry about on Mars is the sand. And you can see here, this is a picture of Spirit stuck in the sand. And one thing that rover drivers have to be careful is that there is sometimes a crust that's on the surface, but below is deep, deep sand. So I have a little video for you right now to kind of show you what it's like when the wheels get stuck inside the sand. And here you can see one of the wheels driving and trying to plow through that sand there. And it looks like it finally gets through at the end. But this isn't the case all the time. sometimes the rovers have to work really hard, and the rover drivers, who are the people who send the commands like we saw in the videos, have to figure out ways in order to maneuver the rover to get out of these sticky situations. But one thing that happened that's very unfortunate is that the Spirit rover got stuck in that sand and wasn't able to get out. So rover drivers put their heads together and tried to find the best way to try and free Spirit. And so they came up with this campaign. It was called Free Spirit. And let's watch a little video on how the rover drivers work together to try and get Spirit out of this sticky situation.
And it's really great to have those engineering models to be able to figure out a solution to a problem like this. So thanks for that, Cherie.
That's one of the most important tools that not only the Mars exploration rovers use, but the Curiosity rover uses. And the rover drivers are incredibly smart engineers and work very hard to get us around obstacles and get us out of those sticky situations. Unfortunately, Spirit wasn't able to leave that post there. All the testing that the rover drivers and engineers did, they weren't able to get her out of that really deep sand. But like Scott just explained to us, it was actually a really great thing for the science team, because they were able to stay in one position, do a lot of analyses, and really get a good idea of what was going on in the area around them. So even though we lost Spirit, their roving capabilities, we were able to continue the science for a long time and explore the properties of Mars. So Spirit has a sister called Opportunity, or a brother, whatever you think, and this is the other Mars exploration rover. And as you guys have already told us, we have Opportunity has traveled the furthest distance on Mars. So let's see a few things that Opportunity has done. One of the first things that they found was this this outcrop called the Burns Formation, and you can see all of these lines here, and that points to a wet history on Mars too. So not only did Spirit find it, but Opportunity did too. And while we were there, Opportunity looked up in the sky and was able to take a picture of these things. Do you guys know what these are? If you think you have a guess, why don't you put it in the chat window? Love to hear what you think.
So you might see a couple of different things, but let us know what, and Leon Spriggs is real quick to let us know they think they see clouds on Mars. Anyone else or any other things you might see? Queen Creek mentions there could be clouds and dust or even clouds of dust. Freedom Middle School and Lewis F. Mayer Middle School also agree that there's clouds. Could also be light northern lights, perhaps some dust storms, and Mars definitely does get some dust storms. Lewis F. Mayer agrees with Queen Creek that these could be dust storms or sandstorms, as Beecher City School says. So it's interesting, but Cherie, what are these things and do they really exist on Mars?
Oh, wow, those are all really great answers. And we had a few schools that said clouds, and that's exactly right. Just like clouds that we see on Earth, we have clouds on Mars. And I'm wondering, for those of you who said dust storms, you know, if we get a bunch of clouds together, we may get rain. Now, we don't have rain on Mars, but I wonder if clouds end up pointing to that we may have dust storms in the future. So there's a lot about Mars weather that we can learn from these rovers. So really great answers, guys. Now, Opportunity also found these really interesting things. These are veins of a mineral called gypsum. And gypsum is only formed when there is water around. So this is just another example of one of the important scientific discoveries that Opportunity has made. And as we look at this is a funny looking rock. And Opportunity found this, and I wonder if you guys might know what type of rock this is and what about it looks interesting to you. Because it sure looked interesting to the scientists who were looking at the images as Opportunity was driving along. So what about this rock would catch your eye?
So in the chat window, let us know. And this observational type of stuff is really important for scientists and science discoveries. It all starts with observations. So Queen Creek thinks could be a lava rock, and it looks somewhat gooey, shiny and glossy. Lewis F. Mayer makes some good observations there. Freedom Middle School says it could be igneous. Lewis F. Mayer notices, and great observation, that there are holes. Gates Intermediate did say there's some surface features that make it interesting, like the holes, and suggest it could be a meteorite. And other schools, including Leon Spriggs, mentions potentially meteorite and metallic. And again, Lewis F. Mayer says metallic as well. Great observations, and those are probably some of the things the scientists noticed as well.
Wow, those are really, really great observations. And you guys are right. This is a shiny rock. And I think Queen Creek described it as gooey, which is a really, really great observation. And I think you guys probably got that because it looks so shiny. And although this rock isn't gooey, it has a lot of holes. It is shiny, and I love the observation, the description of metallic. That's a really great word. And as scientists investigated this rock a little more, they found out that it was a meteorite. And this is the first time we've seen a meteorite on another planet. And so really, really great observations. And it's observations like that that scientists use to try and define where they want to go, what rocks they want to look at. And because we see a lot of igneous rocks on Mars, it was great that we could go and explore and see if this rock was igneous or if it was something new. So really great answers, everyone. So as Opportunity has another thing that it discovered, and I know a lot of you have asked questions about these in the past, but these are blueberries. And they're small spherules made of a mineral called hematite, which is an iron-based mineral, And a lot of times hematite gives Mars that red color. And so blueberries were a big find that Opportunity found not too far from its landing site. And not too long ago, actually in the past few months, Opportunity has imaged these little round things again. And guess what? A lot of you might think that these are blueberries, and that's what a lot of scientists think. But after looking at the chemical composition and what they're made of, they're completely different from the blueberries that Opportunity found almost 8 or 9 years ago. So Mars always has surprises, and scientists are always trying to figure out what exactly has gone on the surface.
And it's interesting because the scientists come up with these everyday words to describe and, to people what they're looking at. So these blueberries aren't edible blueberries you might have with your lunch, but they're just the shape and about the size of blueberries.
That's a good point. So I'm wondering what scientists are going to call these round things. I guess it can't be blueberries, so maybe you guys can come up with a fun thing that scientists may call these round sphere-like objects in this rock. So as Opportunity continues to explore Mars, I'm sure there will be many more science discoveries. Now let's take a look at our newest rover. This is Curiosity. And Curiosity has only been on Mars for 194 days, which is short compared to the over 3,000 Mars days that Spirit and Opportunity have been exploring. So some of the neat things that Curiosity has done is, one thing we have here is different from the Mars rovers. Curiosity was able to film its own landing. And here we can see that heat shield dropping away as Curiosity was heading towards Mount Sharp. So there's some really new things that as we continue exploring Mars, we can continue to improve our future rovers. Another thing that Curiosity has found is very similar to what Spirit and Opportunity found, is evidence for past water on Mars. And from these pebbles, they're very rounded, scientists think that there was once a river flowing on Mars that were able to round those pebbles. And one of Curiosity's stops was a place called Rocknest. And here we had a small sand dune. Curiosity used its big arm and its scientific instruments to take scoops out of this and deliver it to its instruments. And what Curiosity found is that the soil and the wind is very similar to what we see from other rovers like Spirit and Opportunity. And lastly, we see here, this is Curiosity taking a self-portrait of itself, and we're at a place in Yellowknife Bay where you can see a little gray part here where we're stopping to do our drilling exploration. And so as we drill on Mars, we're hoping to find really neat things. And I have a picture of that drill hole that we've just made. And in the coming weeks, the scientists are going to work to analyze this type of material that they've drilled into. And we've drilled about 6 centimeters into the rock and have sucked up that powder and are going to test it with our science instruments to see what type of rock this is. But Curiosity's real goal is to head towards Mount Sharp, where we see these layers and canyons and really big mountain that's in the distance. And as Curiosity heads that way, we see we have a long way to travel. So we have our landing site in green, and this blue dot that says Glen Elg is where the rover is right now. And we have a long, almost 8-kilometer drive before we reach the base. And that's the main mission of Curiosity, is to get to the base of Mars, or of Mount Sharp, and explore the layers and the canyons and all of the interesting minerals and stuff that we see from orbit to see what is going on and how this mountain was built. And so as we move on towards Mount Sharp, we also have to think about our future rovers and what we plan to do. And back in December, after Curiosity announced some of its first scientific findings, NASA announced that there would be a new mission to Mars in 2020. And while the details are still vague and there's a science team defining what we want to do with that mission, scientists and engineers around the world are really excited to think about the possible science instruments that we can put on this new rover and where we want to explore and the new things that we want to try and learn by using this new rover. So I have a quick question for you guys, and this is something that you may want to think about as you continue to learn about Mars and how we explore on Mars, is if you were designing this 2020 mission, what would you do different to the rover? Would you have different science instruments? Would you have a new capability that the rover could do to explore different parts of Mars? Or would you use some of the same things that rovers have used in the past? Would you use solar panels? Would you have different cameras? There's a bunch of different opportunities that we can do and different instruments and capabilities that we can put on this 2020 rover. So it's something to think about, is if you were designing this rover, what would you do? And as we look forward to this launch in 2020, we can only imagine what the NASA Mars rover in this mission is going to do. And I'd love for you guys to keep an eye out, because all of the rovers in the past have been named by people, have been named by kids and kids your age. So keep an eye out, because you may be able to name this future rover. So as we look forward, I hope you guys stay tuned for other presentations that we have, because Curiosity, it has so many more opportunities to explore Mars, explore Mount Sharp, and has a lot of science that it's going to uncover in the future.
Excellent. So like Cherie says, stay tuned for more discoveries. Now, with that, we wanted to make sure that we saved a good 10 minutes or so to be able to get some questions from you guys, so that while Cherie was still on the line and while you were still with us, we could answer some of those questions. So if you have some questions, I'll ask that you put them into the chat window, and then I'll read the questions so we know which one we're answering, and then we'll get to as many questions as possible. One little side note, at the top of the hour, we will sort of officially end, but for those of you that would like to stay on the line to ask some additional questions, I believe Cherie is available to stay on for some extra time with you. So we'll get to as many questions as possible, and I think I already saw one pop in the chat window from Queen Creek, and they said, I would keep, they were mentioning about their rover. They're saying that they would keep wheels, solar panels, but get some rockets so that it may hover over the poles. So they were actually giving us some information about their newly designed rover for the 2020 mission. So very interesting, Queen Creek, and you've got to think creatively, and it does sound like you've done that. So here is a question from Lewis F. Mayer Middle School. When do you think we will send people to Mars? There's a good one for you, Cherie. What do you think?
Oh, wow, that is a great question, Lewis F. Meyer. I have no idea. And the goal originally was by 2030 to have a mission to Mars that included human exploration, but I think we have a little longer to go. So if I had to guess, maybe I would say by 2050. Now, don't hold me to that. I have no idea. I think it's something that's still up in the air, and we have a lot to learn about Mars, like what's harmful to humans and how we can send those explorers safely to Mars. So there's still a lot to learn.
And it really is a great question, because they are doing some of the groundwork to sort of be able to be prepared to send people. And unlike our robotic explorers, when it comes to sending people, we've got a lot of considerations and a lot of safety issues we need to make sure we have addressed so that we can get our people there safely and bring them back. So sometimes that time delay is just a matter of we want to make sure the time is right and everything is in place for those humans to get there and back safely. So great question from Lewis F. Mayer. We've got another question from Gates Intermediate. Is getting stuck in sand more of a problem or less of a problem with Curiosity because of its size?
Ooh, that's a really great question, Gates. And it's actually about the same amount, I guess how to word this, but it's not more or less, it's about the same level of a problem. Even though Curiosity is much heavier than the other Mars rovers, you'll see that its wheels are bigger. And because it has bigger wheels, it's able to traverse through sand just about the same as the Mars exploration rovers, Spirit and Opportunity. I think it has a slight advantage that it may be able to move, maybe not quicker, but a little more, a little better through that sand. But it's still an issue that the rover drivers pay attention to very carefully.
And for you people that have to drive in the snow, you know that it's a lot easier to get through the snow if you have a bigger truck with better wheels to be able to have some good traction. And I'm sure they've learned a lot of lessons from the sand-stuck issues with Opportunity and Spirit, that they make sure that they can stay away from those problems. But it's a very interesting question, Gates Intermediate. Now, Freedom Middle School is asking a question that has probably been on the minds of many even during launch, but are they worried at all about this nuclear power source, about it exploding, or about it having any problems on the surface? So can you speak to that at all, Cherie?
Sure. This is something that we don't worry about exploding. It's not quite like a nuclear power source that you would see, people putting bombs or something like that. It's actually a power source that NASA has been using for a really long time. And all those missions that go out to explore Jupiter and Pluto and the planets far beyond use this type of source. And basically it works by, it has a type of, I think it has plutonium in there, and it's a non-reactive type, but as that plutonium decays, it produces heat. And that heat is used in two ways. One way, it's converted to energy, and that's what we use to power the rover, the instruments. The other way is that we save some of that heat to keep our instruments warm. And I saw another question about how cold it is on Mars, and that's a good question. We want to keep the rover warm because the average temperature on Mars is about minus 53 degrees Celsius, which is about minus 64 degrees Fahrenheit. So as you can tell, that's very cold, and some of those electronics don't like being cold, so we have to keep them warm. And that's one way that that power source is used.
And that's a great answer, Cherie, and that nuclear power source will allow them to be able to have a longer lifespan on Mars and be able to achieve much more science. So if you remember, Cherie mentioned with the Sojourner Truth rover, a successful mission was if that mission lasted for 7 days. And it was able to last for 83 days, as Cherie mentioned. For the Curiosity rover, I believe their expectations for the lifetime and successful mission would be about 2 years. So hopefully with this type of power source, we can last a lot longer. So great answer, great question. Here's another question, Cherie, related to these rovers, and I'll sort of combine a couple of them. Louis F. Mayer was wondering, why do most of these rovers have 6 wheels? And related to that, how long does it take to sort of travel a mile, if you can answer to that as well?
Well, those are all really great questions. So the point of having 6 wheels is it's called a rocker bogie design, and it's a design that engineers have used for years. You can tell the Sojourner rover also had 6 wheels, and it allows the rovers to have better mobility as they're traveling over rocks, and like the Opportunity rover was able to drive backwards and forwards, we can see that each of these wheels is powered separately. So a lot of your cars will have 2-wheel drive, so that, your front wheels will move and power your car forward, but these rovers are able to basically have 6-wheel drive and are able to move all those wheels separately. So it's a design that engineers have come up with that really works based on the surface conditions of Mars. And so some of you have asked about how fast these rovers can travel, and I think you'll be surprised. They're not fast at all. And to go about a mile, well, that really depends on how far the, I guess how fast the rover drives depends on how many obstacles are in front. And if there's a clear path, we can tell the rover to go this far, 500 meters. And as long as there's nothing in its way, then the rover will have a top speed of about 4 centimeters per second. And that's not very far when you convert it out to something that's kind of more, I guess, in your guys' realm of things. So 4 centimeters is about 2 inches per second. So it's not very fast at all. But remember, that's at top speed. And typically the rover travels a lot slower than that.
And aside from the obstacles that might sort of slow the rover down, the interesting stops along the way might cause a mile to occur over months and months of time if there's a whole lot of things the scientists want to stop and take a look at in the meantime. So a lot of things to think about as far as those driving and traverse planning stages. Now, before we get into any other questions, I do see it as at the top of the hour. We're going to stay on the line to be able to answer as many questions as we can. But for those of you that need to depart to get to your next class or to get to lunch or whatever the case may be, we are so glad that you were able to join us today. Cherie, I really appreciate you taking the time out of your very busy planning schedule to be able to join us and these students. So for those of you that might have to depart, thank you for your time, and I hope you appreciate Cherie's time as well. For those of you that can stay on the line, we're going to continue answering questions. So Cherie, one of the other questions that I saw out there was, let's see, what is the air of Mars composed of? Can you tell us about the air or the atmosphere on Mars?
Ooh, that's a great question. The atmosphere here on Earth is totally different from the atmosphere on Mars. And the majority of the atmosphere on Mars is composed of carbon dioxide. And that's very different from Earth, where most of our air is composed of nitrogen with some oxygen and different other elements. But if we were to travel to Mars, we wouldn't be able to breathe the atmosphere because there's not enough oxygen. And so we would have to design some type of spacesuit to where that carbon dioxide wouldn't be harmful to us. That's a great question.
And it's interesting because it ties into the whole idea of sending humans to Mars. We have to be able to find a way to sustain, for humans to be able to explore the surface because they can't breathe that air, as well as the fact that it's really cold. So it is very interesting, and that atmosphere certainly is very different. So one of the groups asked, and this was Beecher City Grade School, they want to know, well, what happened to Spirit? Where is it now? What is it doing? What happens when a rover sort of dies?
Oh, that's a really great question. And, you know, Spirit was only supposed to last for 90 days on Mars, so originally had a 3-month mission, but it lasted actually 3,248 days before it died. And it's kind of interesting how a rover dies on Mars, is once rovers land on Mars, we can't bring them back, so they don't have a way to get back to Earth. But Spirit was traveling, trying to explore this area called home plate. And let me go back to this slide and just show you where it got stuck. And I'll point out, oh, there we go. You can see that it looks like it's hard ground here. But sure enough, right under this was a deep place of sand. And you can see its wheel here stuck pretty far in that sand. And so what happened is Spirit was stuck there. We watched a video that showed the rover inside the test bed trying to figure out the properties of the sand how it was stuck and a way to get out. But when engineers finally determined they weren't able to free Spirit from that sand pit, it turned into a mobile science station. Well, I guess it wasn't mobile anymore, but more of a stationary science station. But the problem is that with the solar panels that Spirit has, is that when Martian winter comes along, the sun is lower in the sky. And so we aren't able to get as much sunlight to the rover, and since we run on solar panels, we need that sunlight to power and to keep all those instruments warm. But as the Martian winter approached, usually Opportunity and Spirit would position themselves so that they were at the right angle to get as much sun as they can. But Spirit wasn't able to because it couldn't move out of this position. So after the Martian winter, Spirit was no longer able to survive and to keep itself warm through that winter, and we lost contact with the rover.
And so unfortunately, you know, these rovers, they do stay in place on Mars, and so Spirit remains in this location, but as that communication ceases to exist, it basically almost becomes like an artifact on the surface. So we can't bring these things back, but it will be interesting as future spacecrafts go to Mars if we're able to image these spacecraft from orbit to see how they might have changed over time due to, you know, any sandstorms, any dust storms. You know, it will be interesting to sort of perhaps be able to make some observations of them in the future. So, yeah, we've got some sort of buried rovers there on Mars in a sense that they're there, but they're no longer communicating with us. But Curiosity certainly is, and Opportunity is as well. So we're lucky to have those rovers still alive and kicking. So, Cherie, a couple of the groups, Queen Creek as well as Lewis F. Mayer Middle School, they're wanting to know a little bit as far as water. I mean, in terms of can we dig down into Mars to find water? What would happen if we did find water? Can you speak a little bit to the water story?
Sure, that's a great question, because all of the things point that Mars once had water on its surface and liquid water, but today we don't see any liquid water on Mars. But what we do know is that towards the poles, the north and the south regions of Mars, that there's water ice beneath the surface. And this was one thing that the Phoenix lander went to explore. And as the Phoenix lander trenched down and dug just a few inches below the surface, we saw water ice. So because of how cold Mars is today and how thin its atmosphere is, there's not a way to have liquid water on the surface of Mars. Now, a lot of scientists think that there could be groundwater, or sometimes, you know, maybe this water heats up enough that it kind of flows, but it's not really certain whether presently there's water on Mars. Now, we think that a long time ago, maybe Mars had a thicker atmosphere like Earth does and is able to trap that heat in, that maybe that's why we see the evidence for flowing water on Mars. But it's still a big question, and that's kind of the goal of the Mars exploration program, is follow the water. So go to these places where we think that there was water on Mars, and try and figure out when it happened and how this water survived and how it formed these different features.
And that whole big water question is really a big one, because when you do life on Earth, we cannot exist without water. And so on Mars, as Cherie said, we have evidence that water once flowed across the surface. And if you think back to Cherie's picture of those clouds, there is water ice clouds high up in the atmosphere. So there's definitely some H2O, but it's mostly in that frozen format. And if you think about, you know, this is just sort of a way to think about it. If you were to take a water bottle to Mars and open it up, because of that cold temperature and the low atmospheric pressure, that water would go from a liquid immediately into a gas, so it's sublimation as we call it. And that's because of the temperatures and the low atmospheric pressure. So there was water perhaps in the past. The state of the water now is really an intriguing question and one that we really certainly do want to follow. Sort of related to that, Cherie, will Mars ever be habitable? Beecher City Grade School was wondering, and that's kind of related to this water issue.
Oh, that's a really, really great question. And you know what? I have to tell you, I have a poster above my desk that shows a painting of Mars and people living on it. Now, I think that's way off in the future, if it's ever possible. But, you know, one thing that we have to think about is that we need some way for humans to be able to breathe safely on Mars, which means we need more oxygen in the atmosphere. Another thing is that we do need water. So maybe there's a big source of frozen water. And if we were to live there, or even to send some of our first explorers to Mars, you know, if you guys have a gallon of water, think if you drink a gallon of water a day. Well, right now it takes us 9 months to get to Mars. And if you had a supply of water for 9 months just to get there, think how heavy that would be. So that's one thing we have to think about in these future missions as we send people there, that we can't take our own water with us. So somehow we have to use the natural resources of Mars in order to survive on the planet and to give us the water we need to survive. So it's a great question, and I know that there's engineers and scientists, even in our own place here at Ares at JSC, that look into these types of things and how future missions, you know, may be able to explore the natural water resources that Mars has, whether it's heat up that frozen water near the poles to give us a water source for future explorers, or how to use the different soils. I don't know, maybe we could grow some plants up there one day. But it's all part of the research and the science that these rovers are exploring, and every piece of data that is sent back is used for so many different sciences, whether it's, you know, soil science or learning about different volcanics, or even how we can live on Mars one day. It's really important, all the info that the rovers send back to us.
And here's a big word for you to think about: in situ utilization. And that really refers to being in a place in situ and utilizing or using the resources to be able to sort of live off the land, I guess, for lack of a better word. So there's certainly a lot of research going on about that type of in situ utilization and using the rocks and using the different resources so that we don't have to carry it all with us. Because that would be a lot of luggage. Think about if you go on a weekend trip and what you bring with you. Now think about a 7 to 9 month travel to Mars and then some time on the surface. And then coming back, that's a lot of luggage, and that's a lot of food and water, as Cherie had mentioned. So a lot of things to really think about and to consider before we take that step of getting our first human explorers on the surface of Mars. So Cherie, here's another question. I think you touched on this a little bit, but can you talk a little bit more about, from Freedom Middle School, they were wondering how do they keep the instruments either cooled or heated and working?
That's a great question. And every day that we do activities on Mars, it all depends on what time of day we want to do them. So let's say we want to drill into the surface. Well, we want to wait until more of the middle of the day where it's warm on Mars, so that our electronics are a little toastier and like to work a little better. But we can work at different times of the day, even though it's not warm enough, just like taking those images at night that we saw, you know, looking at the moons, the Martian moons. And the way we do that is we use power to heat the different electronics. And so on the Curiosity rover, since our power source produces heat, we can use some of that natural heat, or we can also turn on some internal heaters that kind of help us warm up those electronics and warm up those moving parts that we need in order to do different activities.
And it's also interesting to think about the testing that they do before they even send these instruments to Mars. So they take these instruments through shaking tests and through temperature tests to make sure that they can withstand the cold that they will have to withstand on Mars. And then, of course, they use all the other heating sort of sources and timing during the day to make sure that they can maximize what these instruments are able to do. But there's certainly a whole lot of rigorous testing that occurs on Earth first before they ever get sent to Mars. So we've got a couple of questions, and you could probably go back to the slides. Queen Creek was wondering a little bit about how many rovers have been sent to Mars, the size of these rovers, and I think you've got a great picture that shows that family portrait as well as the sizes of our 3 current rovers that have been sent to Mars. So can you talk a little bit about these and give us a perspective of a human and size or something to relate the sizes to?
Oh, that's a great question. So let's start with the Sojourner rover. You can see here. Now, you guys could pick up this rover no problem. It only weighs about 25 pounds, and it is about a foot off the ground, so it wouldn't even come up to your shin. So it's a small rover.
Like a microwave almost.
It is. That's a great comparison. If we look at the Spirit and Opportunity rovers, now those guys were a little bigger. They were almost 400 pounds, and they came up, if you were to look at, you could probably look this rover eye to eye. It was about 5 feet tall, just under 5 feet. So it's more about the size of maybe a shorter human. Now, the Curiosity rover, you can see, is huge. It's about the size of maybe a Mini Cooper car. So it's about 10 feet long, about 9 feet wide, and a basketball player could look this eye to eye. It's about 7 feet tall. So if a human were to stand up next to this rover, maybe the average human would come up to about here. So it would be much taller than a human. And it weighs about 2 tons, so almost 2,000 pounds, which is far heavier than any of the other rovers combined that we've sent.
And it makes me think about that whole idea of the few different options we have to send rovers to Mars, either using the airbags, which both the Sojourner Truth rover as well as the Opportunity and Spirit rovers used airbags to get to Mars, the crane system that Opportunity used, and then that whole idea of the retro rockets, which the Phoenix lander that Cherie worked on used, as well as the early Viking missions used these retro rockets as well. So it's interesting to think about. Size does make a difference in the type of landing design that the engineers end up feeling is the best way to get those to Mars. And those airbags are absolutely amazing, because as they do encase these rovers, even if they're the size of a golf cart like Spirit or Opportunity, those airbags around them are you know, pretty tall in the sense of to make sure that you have enough airbags to cover that whole robotic explorer. It's quite a bit of airbags, and it's quite a bit of surface area, so to speak. So we have a question that's also from Queen Creek, which is kind of interesting because we think about how cold it is on Mars, and you've talked about how cold it is. So they're wondering a little bit about, well, how does lava from volcanoes flow, or how has it ever flowed on Mars if it's so very cold?
That's a great question. And you know, we think that the volcanoes that were active on Mars were active a long time ago. And so we think that Mars was warmer, and actually that probably some of these volcanoes contributed to the type of atmosphere that Mars had in the past. So even though it's really cold, it could be that in the past when the lavas flowed, it was much warmer, so that lava was able to flow better. But also, a difference between Earth and Mars is the gravity. So if you were to go to Mars, you would weigh about 1/3 as much as you would on Earth. And so there's a lot less gravity to try and restrict that flow of lava on Mars. So there's a lot of different things that could have made lava flow easier. So it's a really, really interesting question to think about.
And it's interesting to think about the whole idea of, Shuri talked about how the atmosphere was likely different in the past, perhaps thicker, allowing liquid water to flow across the surface. And it's also interesting to think about the interior of Mars may have once or likely allowed molten lava to be able to come out onto the surface with these volcanoes. But we don't really know how long it's been since any of the volcanoes have last erupted. We don't know if those volcanoes will ever erupt again. And so it's very interesting to think about the fact that this planet has certainly undergone changes, and as many of you probably know, it's the home of Olympus Mons, the largest known volcano in our solar system. So we definitely know lava has flowed in the past, but that future of whether or not we'd ever have volcanic eruptions again in the future, very much not known. So it's interesting to continue to learn about Mars and what some of those things might happen in the past or in the future related to whether it's water or even volcanic eruptions. Now, Queen Creek has added a couple of questions here. Do you bolt together or stream together or seam together rovers? And so how do they sort of put these rovers together? I think I can rephrase that question.
Oh, wow. You guys are future engineers out there. That's a really great question. You know, there's a bunch of different ways that they keep these rovers together. Sometimes they'll use special glue for certain parts if they want to keep maybe some wires down. There's a lot of bolts and a lot of screws that keep all these things together. And there's also, you can weld parts together to make things really nice and seamless, but there's just like you would put together a car and how there's bolts and screws and different types of ways that you build a car is kind of how they would approach to build a rover.
And that's a great point, because there is certainly a whole lot that, you know, if you're driving a car, you want to make sure it stays together. Same thing with our rovers on the surface of Mars. We certainly want to make sure that they stay together, and there's certainly a lot of testing that they go through to make sure that they do, that they are put together well enough so that they can do their job on Mars. Now, I don't know if you can answer this question, Shuri. I know I don't know the answer to this question, but do you know in terms of watts or wattage the kind of power we might use on Mars, whether it's on a daily basis, or can you tell us anything about the amount of power that's used to have these rovers do their work?
Oh, that is a really good question. And, you know, I don't know exact numbers for you, but it's really interesting because day to day, there's a certain amount of power that the rover is allowed to use. And so we don't want to dip below maybe like 40% because we need to have extra power in order to just keep kind of the background things going. So keeping those extra heaters we need or certain things running, you know, being able to communicate, that all takes some power off in the background. And so from above that, that gives us about 60% of our total power to use for science during the day. And there's different things we can do and different instruments that require different amounts of power. So let's say one day we want to take a bunch of pictures, and then we want to move the arm and use one of our science instruments on the end of the arm. Each one of those things requires a different amount of power. So in order to turn on the cameras and take pictures for an hour, let's say maybe that's, 200 watt-hours. But to move the arm, especially if we have to heat it, that may take more power than it does for an hour of taking pictures. And so each day when the science team puts together their plan, they have to keep an eye on how much power they're using. One of the big instruments that we're using to try and find organics is called the SAM, and SAM uses up a ton of power. So if we're going to do SAM on one day, then we have to kind of cut back with some of the other science we do. So it's kind of a play with how much power you use, and you kind of have to be careful and decide, base your science off of what different types of observations you do that day.
That's a really interesting, and thanks for, that was a great explanation of that. And, it made me think of, like, if you get an allowance and you have so much money to spend during a week, you have to pick and choose what you want to spend your money on and how much you want to spend on a given day or save for a given day. And it made me think of that's sort of how, they have a certain amount of power with the Rovers, so they have to have a give and take of what they're able to use and what they save. And I'm sure that instrument scientists that are sort of these lead scientists for a given instrument, they all want to use the power to be able to use their instruments and get data for their own scientific purposes as well as the mission as a whole, but it really is a very delicate balance. So, Cherie, I see one other question that has come in with regards to the material used to make, like, the back shell to go through this heated environment when it's going through the atmosphere. Do you know what any of these, the types of materials that are used for these rovers, or the back shell in particular?
Paige, I'm not exactly sure, but my best guess would be, just like if you guys have seen pictures of the space shuttle, and you see all those tiles that are on the bottom, that's made of a type of ceramic that can heat up, that you can, almost like a clay pot. It's that type of material, but really special. And it's able to take really, really extreme temperatures before it breaks. And so my best bet would be that heat shield, as it's moving through the atmosphere, it experiences incredibly hot temperatures. And so it would be a type of material like that ceramic that would protect the insides of the rover and the lander or whatever you're sending to Mars so that it wouldn't heat up. So that's my best guess, but that's a really good question.
Yeah, and they certainly want to make sure that they use materials that would be able to withstand those heats and those amounts of heat. And they certainly, again, they do that testing to make sure that, that they've got it right so that we can actually get to the surface safely. Now, Cherie, if you'll go to that distance slide to be able to, again, show us a little bit in terms of how far these rovers have traveled. And, if you could just say a little bit in terms of, the amount of distances according to the amount of time these rovers have been there, what does that equate to sort of on Earth, if you can make any of those kind of comparisons?
So one thing you'll see is that even though Opportunity and Spirit were on Mars and, functioning for about the same amount of time, besides Spirit having a little less time there, you can see Opportunity traveled much further distances than Spirit. And this is because, we don't go to Mars and send a rover to Mars and think, well, our goal is to travel 20 miles. It's actually all depends on the science and the different types of things that the scientists see once they get to Mars. And so overall, they have a goal of where they'd like to go. Just like Curiosity, our main goal is to get to the base of Mount Sharp and travel up Mount Sharp. But where we are right now is all because scientists have found some really interesting things along the way. So Opportunity has traveled many distances because their goal was to head to a big crater called Endeavour Crater. And so Paige, you may know this, but I think it was for about a year. They just did nothing but drive.
Mm-hmm.
been a long time just trying to get to its destination. Whereas Spirit was exploring those Columbia Hills and home plate, and because scientists found so many interesting things there, the rover didn't have the goal of driving to another distance. They really wanted to try and figure out what was going on. So it's really all about the science is kind of what determines how far these rovers end up driving. Now with Sojourner, that was kind of a different story because the rover could only travel about half a kilometer from the actual lander. So it didn't have its own way of communicating with engineers back on Earth. It had to communicate through its lander. So it kind of had a range that it was only allowed to get so far away from the lander. But, you know, here on Earth, if 22 miles, I mean, when I go to school every day, I drive about 22 miles, just one way.
Or if you think about marathon runners, in 3 to 4 hours, they're traveling the distance that Opportunity traveled in the last, you know, however, 8 years or so.
Exactly. So it's really crazy to think that it took 9 years for Opportunity to travel just 22 miles, where, like Paige said, would only take about 4 hours for someone here running on Earth. So it's really interesting. And you know, earlier I mentioned that there's kind of two ways when we saw that video that rovers can travel. You can say, go to this rock and it will find its way there, or you can just tell it, you know, drive straight 5 meters. And, you know, usually you have to use the avoidance techniques, and so your rover drives a lot slower than if you were to just tell it to directly drive to something.
And it's interesting to think about those distances and think about how many miles it is to get to school. And maybe you drive, like Cherie drives to work 20 miles or so. Maybe you drive 20 miles from where the bus picks you up to get to school. But then if you think about even Sojourner or Curiosity being 0.3 miles or 0.4 miles, if you think of a track, and a track is about 1/4 of a mile around, that at least gives you a perspective of the amount of distance, especially in terms of maybe Sojourner and Curiosity. You know, doing a lap around the track or 2 laps around the track as Curiosity gets closer to that distance gives you at least a little bit of the perspective of the of what those distances really mean. So it is interesting to think about that, and so thank you for the question. And so we're going to do maybe 1 or 2 more questions before we wrap things up. And so from Queen Creek, one of the really interesting things they mentioned, Cherie, is could you make a resort kind of place for rovers so that they could rest and recharge on Mars?
Oh, wow. That is a really interesting question, and it sounds like you guys are really thinking outside of the box. And I wonder if our engineers and planners who are kind of looking at these future missions are thinking about that same thing. So that's really interesting. I've never thought of that. It's almost like we would have to put a base on Mars, or like we have a space station orbiting Earth right now where we can send astronauts and they can rest and do their science up there. Maybe we would have a base on Mars to where rovers can drive up and kind of recharge their batteries. You know, I've never thought of that. Really, really great question, Queen Creek.
Yeah, it is interesting, and at least we have those natural dust devils that can help sort of naturally recharge. But to have some type of resort kind of place for those rovers, right now I guess we just use those self-improvement techniques or creative engineering. I think of Cherie mentioning how with the rovers, especially thinking of Spirit, how they would literally tilt the rover to sort of face the sun during the winter time to make sure that it could get as much energy as it could from the sun. And so I would say that we use some sort of techniques, whether they're natural dust devils or this creative engineering sort of deal where we can tilt the rover so that it can, you know, get more power from the sun, is our best kind of resort that we can resort to these days. So, but it is interesting to think about that for the future. And Cherie, I think our last question for you today before we wrap things up is, Mount Sharp, you've mentioned it for curiosity. What is so interesting about Mount Sharp? Why are we wanting to go there? What's up with Mount Sharp?
Oh, that's a great question. I'm going to flip to one of these slides towards the end where we were looking at that kind of picture in the distance. And so I'll point out a few things that scientists are really interested about. So as you can see, all of these layers, it's almost like if you guys, I know Queen Creek, you guys live in Arizona, so maybe you guys have been to the Grand Canyon. And if you look at the Grand Canyon, you see all of those layers there. Well, that's exactly what scientists want to look at, is all of these layers. And scientists think that maybe these layers were deposited by some type of process that involved water. Now, if I switch to this next one, I'll kind of show you. We have a bunch of sand dunes down here. But as we get to the base of Mount Sharp, there's different types of minerals that we've been able to identify from some of the science instruments orbiting around Mars. And so towards the base here, we think there are clay minerals. And clay minerals are formed by water. And this is one of the biggest areas on Mars where we see these type of minerals. And as we move up, we have these sulfate minerals. And these also need water to form, but a little less water. And then we move up even further and we see these cracks. And we think that these cracks were filled in by minerals as water rose up and kind of went into these cracks and made these other minerals. So each place we have 3 different types of areas on Mount Sharp that all had a different water story. And so that's why we want to go to Mount Sharp, is so we can try and figure out what the past was and how this mountain actually formed.
And it's interesting because she said the water story, and really these missions are piecing together, it's almost like detective work, where you're piecing together the story and the history of what made this location the way it is today, and interestingly enough, what was water's role in it, so that we can better understand this story here, and Mount Sharp is certainly a big part of that. So with that, I want to thank again the groups that were able to stay on the line and ask some questions and hear answers to questions. We so appreciate your interest, your intrigue, and your insight into some interesting things that I know have made Cherie and I think about some of your questions and comments. So thank you for that. I also want to thank Cherie for taking the time. Every day she is a part of this mission and the planning as they decide what they want to do. So we certainly appreciate Cherie's time to share this story of Martian rovers, past, present, and future. And so thank you, Cherie, for doing this for us. And until next time, everyone, we look forward to connecting with you again in the future. So thank you, Cherie. Thank you, school groups. And Cherie, any other closing comments?
I just want to say thank you, guys. It's been so great for me to be able to share all what's going on in the missions and about past missions. And I'm so excited you guys are interested about Mars. So thank you from me.
Great. Well, thank you again, everyone. And